Hello, this is FlippedHarber for Physics, and in this video we'll talk about forces. The outline for this video, we'll talk about what a force is, we'll talk about the difference between contact forces and field forces, we'll talk about what a free body diagram is, we'll look at adding forces, we'll look at two of Newton's three laws of motion, and we'll end by talking about equilibrium. Now, a force is simply any push or pull on an object. It's one of the most basic ideas in physics. It's a vector quantity. That means that the direction of the force matters. We use blue arrows and graphs when we talk about forces. And we're going to find out later that forces are very closely tied to the acceleration of an object. We'll talk much more about this later. Now, there's two basic types of forces out there. There's what we refer to as contact forces and forces that we call field forces. A contact force exists when two objects are in contact. Examples of this would be friction. Friction is a contact force because two objects have to be in contact, be rubbing together in order for there to be friction. When we stack objects on each other, they push down or hold each other up. And then colliding objects like pool balls or cars in accidents, they apply contact forces to each other. Field forces are forces that act over long distances, and they don't actually have to be in contact with each other. The two classic examples of field forces are gravity and magnetism. Now, a free body diagram is a picture of an object that we want to talk about, and we draw the force vectors acting on it. Now, if we talk about a physics book sitting on a desk, if we're drawing the free body diagram for the physics book, we draw just the physics book. We don't draw the table that it's sitting on. We don't draw the chair in the room next to it. We don't draw the teacher standing next to it. We just draw the physics book. And then we start adding blue arrows, blue force vectors, and label them according to what's causing the force and how big it is. So probably the most basic force to talk about first would be that of gravity. That is a force that's caused by the Earth pulling this physics book down. Since the physics book is sitting on a desk, there's an upward force that's coming from the desk that's keeping it from falling due to gravity. We call that a normal force. Now we'll talk about normal forces more in another video. But right now, the normal force is just the supporting force from the table. Now, when we add forces, because they're vector quantities, the direction that those forces act matters. So in our first picture, where one guy is pulling and one guy is pushing, we would add those two forces up because they're both positive forces. They point to the right, which is our typical positive direction. Now, our second picture, we have two guys pulling to the left and one guy pulling to the right. So we take the two forces and subtract the one force to find out that our net force, that is when we add up all the forces, it's one force to the left. Net is just a mathematical word that means add up. Looking at our big picture in the bottom, we've got three guys pulling to the left. They label that as the drag team. We have four guys pulling to the right. So when we do a sum of forces, when we find our net force, we take four forces minus the three forces, and we find out that our total force is just one force, in this case pointing to the right. Now, that weird E looking thing in front of the F, that's the Greek letter sigma, and it means to add up. You're going to be seeing that a lot when we talk about forces. That sigma F means the sum of forces. Just add them all up. Now, let's talk about Newton's first law. Newton did a lot of work for us in the field of motion. He's most famous for gravity, but that was just part of what he did. Probably his biggest contribution is his laws of motion. They're still used today. They're very, very important. Newton's first law says that an object that is at rest will remain at rest, and an object that is moving will continue to move in a straight line with constant speed if and only if the net force acting on the object is zero. So Objects want to continue moving or they want to stay at rest unless there's a force acting on them. If anything is traveling in a curved path, there's a force acting on it. Anything that is speeding up or slowing down, there's a force that is responsible for that change in the speed. Now this law tells us that forces are responsible for causing changes in velocity. That is, that forces are responsible for acceleration. Again, I told you that forces are very closely tied to acceleration. So now we're going to start to see that relationship. Now, as a matter of fact, Newton goes on with his second law and he says, okay, forces cause acceleration with the first law, but with the second law he actually tells us how to find how big that force is. So Newton's second law is basically an equation. Force is equal to mass times acceleration. If we apply a bigger force on an object, it's going to cause a bigger acceleration. Now, this law tells us how to calculate the force acting on an object, and if you take 1 kilogram of mass, that's the standard unit for mass in physics, and you multiply by 1 meter per second squared, that's the standard unit for acceleration, you get 1 Newton of force. Now Newton didn't name it himself, we did that later in honor of him. So the standard unit for force is the Newton. Now let's talk about equilibrium. Whenever you hear the word or read the word equilibrium, it simply means that the object is not accelerating. This does not mean that the object is not moving. An object traveling at a constant velocity is in equilibrium. That means that there's no acceleration. That means that the net force is 0. Okay. So that's the end of our video on forces. It's time to get to work. There's some videos on some practice problems that you're going to need to watch also. I'll see you in class and I'll see you online.